technologist, and I work at the Vienna University of Technology. And what I want to present is an approach which is called visual analytics. And I want to show you what is the content of visual analytics and how you can use the idea or the methods of visual analytics to detect the expected and to discover the unexpected. And what my plan for today is that, or for the 20 minutes, is that I first give you some motivation, why, a very short motivation, why we need some kind of visualization, what is a good thing, and I will tell you one success story, and then I will show you some problem areas which are important to tackle the information gaining in a huge data set. Then I will explain you shortly what is visual analytics, the concepts, and why is time important. And my main focus will be that I show you how you can apply visual analytics for different kind of application areas. And first I will show you how visual analytics can be particularly applied for analyzing time-oriented data, where time plays a particular role and where time is not a normal attribute, but also where time is an attribute which is a particular characteristic. And the second thing I will present you shortly is some ideas about text visualization and how text visual analytics can work. And I will catch you some project from colleagues which try to get some content out of text or documents, huge collection of documents. And I will end up with some challenges and conclusions what in the field of visual analytics is currently going on. The first success story, maybe everybody knows, there's a very important book from Edward Tufte, and he had collected a lot of different success stories, and one success story is the story about the mystery of what caused the cholera epidemic in London 1854. And if everybody knows, there was the cholera, it was in London, the people were ill, and we didn't know what happened directly, why this cholera happened. There were a lot of guesses, but nobody knows. And then there was this Dr. Snow, and Dr. Snow was a famous doctor, and he could convince that he make a survey. And what he did is he collected on a street map of London, who collected all the different people who died on the location and made such histograms here. Here collected where the people died due to cholera, and the next thing what he collected, he also marked where the pumps are. For example, here is a pump, here is a pump, and here is a pump, because he had the hypothesis, or had the idea that there could be some correlation between water and dust in the water and the cholera epidemic. And then he found out that there is a correlation between, here is a pump, and here's a lot of many people who died due to water or dust or bad water. And what he convinced the people in London that they give away the handle of the pump, and then the cholera epidemic was decreased. And this is one nice success story where you could help, with a visualization to show the dependencies of different hypotheses, different ideas. You can't prove it with visualization, but you can find hypotheses, what are the correlations. And this comes to the motivation why we need visual analytics. I think everybody is aware that we are currently suffering a lot of information overload. We have a lot of different data, and we have a lot of different heterogeneous data sources, and we have a lot of different interdisciplinary fields, and we are missing that the users and their tasks are connected. Here are the men who were collecting paper. Now we are collecting bits and bytes and documents, and we are still in the process that we need to analyze the data, and we don't know what's going on. And this brings us to the idea we need some different methods to solve this. One idea is to use visualization. Another idea is that you use analytical methods. And the third idea is you use interaction, that you can explore the data. What we understand from visualization, what is the important thing in the case of visualization is, here is my simple famous example. What we do is, if you see this data here, you don't see a lot if I ask you what you see in this data. If I annotate this with semantic, and tell you these are 3 rows. Do you see anything in this data? If I help you again and tell you this is the numbering, this is the X and this is the Y coordinate, do you see now anything?
No.
No. What we do is, there's where the computer comes from. We annotate the document, the text, or the data with semantics. Then we use the computer to help us. In this case, the computer can easily, if I tell them, this is the numbering, this is the X, and this is the Y coordinate, I can easily compute how this is be on the XY coordinating system. And now, can you tell me what you see here? You know it from your childhood. Painting by numbers, yeah? Yeah? No, but you're close, yeah? It's an elephant and a palm tree, yeah? And this is exactly what we wanted to do with visualization or with visual analytics. We don't produce beautiful pictures, yeah? This is not our aim. We are not computer graphic person. We draw pictures where the human can draw some conclusion out of it, where the human gets insights. Yeah? Therefore, it's very complicated for a computer system to really understand that this is an elephant and a palm tree. But if you look at it, it's quite obvious that this is a palm tree and an elephant. This is the case of visualization. This is what we wanted to do with visualization. The second thing is analytical methods. A small example is, if you think about the screen resolution, then you can draw around 800,000 bits. If you see each data set can be mapped to 1 pixel. When you look how many yearly measurements of water levels we have in Lower Austria, more than 5 million, this means we need such a big screen. And you couldn't do this example further on. If you think about the number of cellular phones in Austria, we need more than 8 million pixels. And if you think about the transmissions between emails every hour worldwide, then you need 35 million. It is obvious if you look at this picture. This is our screen. Now the screens are much larger, but still the relation stays the same. We need some methods which reduce this overload of information to be printed on the screen. And this is done applying analytical methods for data reduction, visualizing the most important parts of information. And the analytical methods, what we are applying is statistics, machine learning, and data mining. And what we wanted to combine is with the visualization, with the palm tree and the elephant, combine this with the analytical method to gain the insights. And we are currently not talking only about, we talk about petadata, exadata, teradata. And the last thing what we want to do, we have now the visualization, and now we have the analytical method. We wanted to combine them, but we also don't want to have some static pictures from the past where we observe them. We don't want to do presentations only, where one fits to all. What we are aiming of is today that we can examine the visualization, the analytical methods, depending on the users who are involved, depending on the different tasks they want to achieve, and depending on which data they have around. And this brings us to the field of visual analytics, which was founded in 2005 by Jim Thomas and Kristen Cook in the US. And they defined visual analytics as analytics is the science of analytical reasoning facilitated by interactive visual interfaces. And the basic idea was, what they wanted to achieve is that you combine visualization and interactions with computation and mining, visualization and analytical methods, and use the results from perception and cognition to present visualization, visual representation of the huge amount of data that the human gain insights into the data. And this was the strap from the US part, and currently there is also an initiative in Europe. This is the VisMaster project, where we defined also a roadmap about problem solving with visual analytics. And the basic idea is that you come up with such a process where you have here the data, here you have a path to visualize the data to gain knowledge or insights or information, and here you have the path about the models, and this is easy. The visual is easy. It's known as information visualization, this is known as data mining, and what we are aiming with visual analytics is the intertwinedness of these two paths. And why is time important? Time is important because when we're dealing with daily lives, time is everywhere. We have different seasons, we have different calendars, we have different time, and time is not only a characteristic of a normal attribute. If you navigate in time, you need particular tasks and methods. And this is the emphasis of my research. And there I want to give you a short overview what is possible to do with visualizing or visual analytics for time-oriented data. And the basic idea is that you have to think about four aspects. One is the characteristic of time and time-oriented data, then the idea of how you visualize time-oriented data, how you can interact with it, and how you can analyze it. I will skip today the part about characteristic of time and time-oriented data. You have to trust me that it's complicated. You have different scales, you have time, you have points, you have different viewpoints, and it's quite complicated. It's not that simple. You have to trust me in this circumstance. Huh? I will go to the visualization of the time-oriented data and will tell you which kind of methods could be used to visualize time-oriented data. The basic idea is that you have two different methods to visualize time. Huh? One is you can map time to time, which is an animation. The other idea is you can map time to space. And I want just to give you a short demo what we're doing with time to space, the animation. I hope that this works now on this beamer. And the basic idea is, this is a research project which is dealing with diabetes data. And the basic idea is that here you plot the insulin, and here in the middle you have the different patient, and here you plot, for example, the date of the patient when the examination was done, and then you can use the animation to see how the patient changed over time. And you see how the different these are patients, and if they are gray, then the examination was from the past, and if it's black, this is a recent examination, and this is the insulin value which is measured, and you see how it is changing over time, and that it is getting better. You can explore that you use the color for the sex, or you use the shape for if it's a smoker or it's not a smoker, and you can use the size to plot again the body mass index. And then you see quite nicely that the body mass index, the bigger is it, that first the people were fat and they get smaller and smaller if they obey a little bit more what they have to do. And what you can see afterwards also, if you can look at the traces to see what's happening. And this is a nice method where you can, sorry, but the resolution is a little bit bad here. So. Sorry. And what you can see then is, this is a classical demo effect, is here you can see the traces. I have problem with the resolution here, and here then you can observe the patient, how he's again the date, and here's the insulin value, and here the different, how the nicotine level he's using, and then you can see how the patient is changing over time, and then you can observe if the patient obeys to the therapy, and if he doesn't obey to the therapy. Another idea is that you use it not only time to time for animation, as I showed you, you do time to space. This is another project which is called Visual Explorer, where we don't want to explore patient cohorts, a set of patients. There we want to explore one patient and want to explore different kind of parameters. And what you see here, you can select a set of different kind of parameters. Here you have the time X, then you have different kind of visualization and see how the patient is changing. I come back to this later on. And the last thing that what you can use is to visualize time is that you can use visual variables for the position, the length, the angle, the slope, the connection, the thickness, to take time into account. That you see, you have a lot of variety to deal with. The second next thing is very important is that you want to take interact with time as well. And therefore, you have really to need about or to think about what is the data, what you explore. Is it time-oriented? Is it quantitative? Is it qualitative? What is the how different kind of variables I want to observe? What are the users, and which are the tasks of the users? And you wanted to develop methods, visualization, which are expressiveness, the sense that they can capture all the tasks, they can show in effective the data, what the user is searching for, and the visualization is appropriate for these tasks. And one idea to deal with, or what you can handle this, is another project where we want to interact, where you show to interact with time, where we combine guidelines, clinical guidelines of patients, which are shown here. And here you show the hierarchy and how the different patients are behaving. These are one parameter. And here you see different kind of actions. And then you have just a lens and explore in more detail how the patient is reacting. And for example, here you want to see how the slope is changing, and you see easily that here one patient is behaving good, he's also behaving here some problems, and the other one is also behaving good. And what you also see here, this is an action was taking first, and then it takes a while, the same action was taking again, and it has some delay effects. Or the other thing what you can interact is, for example, for the Visual Explorer project, you want to know what's happening, you want to explore how is the time delay between one task or one visualization and the other one, and we have such a tool measure where you can really measure easily what is the time between the different time elapsed. So, and the last thing, or the last issue what is important is that you analyze time-oriented data, which is again some methods. We start with simple statistic methods, and which deal also to handle more sophisticated data mining and knowledge recovery in databases, techniques which start with simple prediction, clustering, classification, search and retrieval, and pattern discovery. And the main idea is that you use this kind of temporal data mining task or the methods, combining with the visualization to gain more insights. And this is quite very challenging in the sense for which task what is applicable and where is the visualization more important and where is the other one. The last thing is what I wanted to give you some clue about simple text visualization, because I thought the audience here is more also interested what is doable with text and documents. And I think you're all familiar, there are a lot of things going on. There are the tree maps where the news are shown, there is this river theme river, there is this idea of island and the different texts, there's these stack clouds of different kind of ideas. You can repeat this on, and these are quite a lot of things going on, and I want to show 4 different small examples, just to give you a clue what's going on here. The history flow, readability analysis, document car, and sentiment explorer. I will, due to the time, only give you 2 of these examples that you get to know what's going on. Huh? The history flow. The history flow is a tool which was developed by Wattenberg and Fernando Vigas, who were analyzing web pages, and they were particularly interested in how the content and the editing of web pages was changing. And what they did is they used at each time step, they traced how much text was changed. And this at version 1 there, Mary added something. At version 2, Susan added something too. And at version 3, there was Martin, he was deleting something from Mary and added some text. And then the next version where there is Mary going on, deleting something and adding something again. And the basic idea is then they connected to the different time stamps, they connected the text which didn't change, and then you get some kind of flow, how the text is changing. And you can do this equally sized, or you can do this that if the time steps are different, then you can do it that according to which time step the changes were done. And this is a quite simple technique, but you can see a lot of easy things when you look at the data. For example, if you look at this data, this is a data set where it shows how fast a web page can evolve. Here's the beginning. Then there was one person who was entering a lot. The white one is an anonymous person, and then a lot of people come and entered more and more data. Another nice example is here. There is a web page about chocolate, and there was a war adding and deleting chocolate. Yeah? text about chocolate, and you can easily see this in the zigzag here, which is quite nice. People were adding, next one deleting, adding, next deleting. And I think it's quite nice. It's a simple technique, but it's quite nice to see here what's going on. The next thing is about readability. This is a project which is done in colleagues of Constance, Daniel Keim's group, who was exploring different text documents, particular articles, in this kind also children literature or administrative text, how you apply, for example, the text you need to apply for European Union projects, and he was introducing different kinds of scores to show the readability. And he may summarize the different scores according to a feature extraction techniques, which I will mention here. And he color-coded it in the sense green is low readability, black is high readability. And what you can easily see here is children literature is easy to read. Text about how to apply for European Union projects is complicated. And what he did here is he analyzed every sentences. And he did this further. He was also analyzing conference papers. And there's a particular conference for visual analytics called Visual Analytics VAST conference. And he analyzed the different VAST papers. And what you can see here, the score is low readability, overall score, blue is high readability, and here are the papers based on sentence and paragraph analysis. Then you see the papers are mostly blue, they have easy readability, but there are also papers which are red, have bad readability. And he also compared, and he did this for other conferences, paper of conferences too, and he also compared the judgment of the reviewers compared to the readability scores, and he couldn't find their relationship. Therefore, the idea that you run your paper in this system and then you increase your readability, then the acceptance rate will be, the likelihood of the acceptance rate will be increased is not the truth. Therefore, readability is one issue. Okay, I will delete this part due to my time thing. There are sentimental analysis where you can explore positive and negative attitudes from different speeches. This was the speeches of the American elections, and also the documents. If it's green, it's positive. It's red, it's negative. And then this other example I skip. Maybe you were familiar with Gutenberg and his thesis. With this plagiat stuff in Germany, there was also a nice visualization to show how many cases this was, and they used a heat map to show that he has really copied a lot of text. Then you can see visual analytics or visualization really helps to gain insights and explore. To sum up, what I tried to show you very shortly is that visual analytics is a challenging topic, and it really helps you to generate hypotheses, but not to prove hypotheses. You need different methods to prove hypotheses, but you can use it to detect the expected and discover the unexpected, if you have something in mind. But there are still a lot of challenges on the technical level. There are challenges concerning the data quality and uncertainty, about the data provenance, how you deal with data streams, how you deal with scalability. Scalability is a big problem in visualization. And how to really integrate the whole overall process. And the next very challenging thing is the evaluation. How you can show that you really gain something with this kind of techniques, and to show that this is the correct visualization, the correct method forward. And of course, there are many other application issues. So this is where the open issues are. If you want to be more interested in some self-advertising, I wrote a book with Wolfgang Eigner and colleagues from Rostock, Heidi Schumann and Christian Tuminski, about visualizing time-oriented data, which is published recently at the Springer. If you want to know more about visual analytics, there is this book about the information age. And if you want to see more about what is in the VisMaster, there's also a video. Thank you very much for listening.